Hello and welcome to today's programming video. In today's video, we will solve the coding interview question called climbing stairs. But before we begin, here's a quick tip. When you're preparing for coding interviews, it is important to understand the approach behind a solution. You should try and avoid memorizing the code. Understanding the approach has two main benefits. First one is that you will remember how to solve the problem, and you can apply the same sort of approach to different problems. So let's get started. So we have been given that we are climbing a staircase, and it takes n steps to reach the top. Each time you can either climb 1 or 2 steps, and we need to calculate the number of distinct ways that we can climb to the top. So if we start at the bottom and just take one step at a time, so we can come to step number 1 and then take one more step, come to step number 2, right? So this is one way to get to the top. Another option might be that we start at the bottom of the staircase and take 2 steps and go straight to the top of the staircase. This will be our second distinct way, right? Is there any other way that we can get to the top of the staircase? No, right? So for the staircase with 2 steps, the distinct number of ways is 2. Now let's look at this example with 3 steps. So how many distinct ways can we get from the bottom of the staircase to the top of the staircase? Let's say we took one step at a time, and then we would get to step number 1, then to step number 2, and finally to step number 3. So this would be our first way to get to the top of the staircase. The next way we can get to the top of the staircase is if I first take 2 steps, right, and then take just 1 step. And this would be my second way of getting to the top of the staircase. The third option is if I first take a single step and then take 2 steps. So the total number of ways in which we can climb a staircase with 3 steps is 3. So here we are with 4 steps, and we want to find the distinct number of ways that we can get to the top of this staircase. So to get to step 4, we need to get to step 3 and take 1 step, or we can take 2 steps from step 2. So let's visualize this. We want to get to step 4, and to get there we can take 2 steps from step 2 or 1 step from step 3. Now to get to step 2, we've already seen that we can take 1 step from step 1 or 2 steps from the base of the staircase, which is step 0. To get to step 3, we can take 1 step from step 2, or we can take 2 steps from step 1. And finally, to get to step 2, we can take 1 step from step 1 or 2 steps from step 0. Now if you look at this graph visually, we can identify the number of paths going to number 4 from all the leaf nodes. Let's count them one by one. The first one is 4, 2, and 1. Second one is 4, 2, and 0. The third one is 4, 3, 2, and 1. The fourth one is 4, 3, 2, and 0. And the last one is 4, 3, and 1. So that's total of 5. So that means the distinct number of ways to get to the top of a staircase with 4 steps is 5. If we look further, we can see that the number of ways to get to step 4 is equal to the sum of number of ways to get to step 2 and the distinct number of ways to get to step 3. Let's count and prove it. To get to step 2, we have 2 ways. The first one is here, second one is here. Now, to get to step 3, we have 3 different ways. The first one is 3, 2, and 1. That's 1 here. And next one is 3, 2, and 0, that's 2. And the third one is 3 from 1, so that's number 3. So again we see here that the total is 5. To get the distinct number of ways to get to step 4, we have to add up the distinct number of ways to get to step 3 and the distinct number of ways to get to step 2. In this approach, we are essentially breaking down the problem into smaller subproblems. And to avoid recalculating the number of ways to get to the previous n- steps, we will store those values in a cache. This is the essence of dynamic programming. In this case, our cache can be an array of size n. So what are the smallest subproblems here? We know that the number of ways to get to step 1 is 1 and the number of ways to get to step 2 is 2. And for any value larger than 2, we can easily calculate the distinct number of ways to get to the top of the staircase. So our base case will be when the number of steps is 1 or 2. We will define an array called ways and store these two values in it. Since arrays are 0 index, 0 represents the first step. So at ways 0, we will store the number of ways to get to step 1, which is 1, and at index 1, we will store the number of ways to get to step 2. We can generalize this and say that to get to the top of a staircase with n steps, we need to add up the number of ways to get to n-1 steps plus the number of ways to get to the top with the staircase with n-2 steps. We'll use this logic and implement the solution. So let's now jump into the code. I'm going to implement the solution in Java, but you can use the same logic to implement the solution in any language of your choice. The first thing we're going to check is if the number of steps in the staircase is 1 or 2. Then we already know that the number of ways is 1 and 2 respectively. So we don't need to do any calculation in those cases. Now we will define our cache, which will be an array to store the number of ways we can climb to the top of a stair. And this will be of the same size as the size of the staircase. At index 0, we will store the number of ways to get to the top of a staircase when there's just one step. And at index 1, we'll store the number of ways to get to the top of the staircase when there are 2 steps. Now for any given value of n which is larger than 2, we can iterate through the values of n going from 3 till n-1 and use this formula here to determine the number of ways for any given I in n. So what we have done in this code so far is we have created this array called ways, which stores the number of ways to get to the top of a staircase with n number of steps, right? So at index 0, we store the number of ways to get to the top of a staircase with 1 step, and we know that it's 1 way. At index 1, we have 2 steps and the number of ways is 2. At index 2, which is actually a staircase with 3 steps, we have added the previous 2 values, so that is 1 plus 2 and that is 3. And at index 3, that's the number of ways to get to the top of staircase with 4 steps, we have added again the previous 2 values and we get 5. Similarly for index 4, the number of steps is 5 and the number of ways is 3 plus 5 and that's 8. So we continue that loop till n-1, and that's why we can say that at index I, the number of ways to get to the top of the staircase is ways of I-1 plus ways of I-2. And finally, we will have the number of ways to get to the top of a staircase with n steps in index n-1. So that means that we need to return from this code the last element in our ways array. Remember, this is a 0 indexed array, so we can't access the ways of n, but we need to access ways of n-1. So let's give this a run. Okay, that's looking good. Thank you so much for watching. If you found this video useful, please do remember to like and share. Thank you. Bye.